The next one in the relation plot is correlogram. It's also known as a correlation matrix or correlation plot. It's a graphical relation of correlation coefficients between the variables in the data set. It's commonly used in exploring the data and analyzing and to visualize the strength and direction of the linear relationship between the pairs of variables. The key features for a correlogram are the correlation matrix, color mapping, annotations, and axis labels. The common use cases where we can use them. So it's very much useful when we are trying to identify relationship between the variables in the data set. It's useful when assessing the strength and direction of correlation between pairs of variables, identify multicollinearity or high correlation between predictor variables in regression analysis, guiding feature selection or dimensionality reduction techniques in machine learning. Yes, we have been talking these issues since many sessions. That is, dimensionality is a curse, so you can do something to reduce dimensionality so that the machine learning task becomes simpler. So, how that can be done? So, one thing, to retain only those parameters which are useful for our work. In such case, we need to identify the correlation between each of the independent variable or the input with the output. If there is any correlation, we can retain that input for further processing. And if we find that the output has no correlation with that particular input, that means it's an extra thing. It is redundant one and is not going to make any improvement in our work. It's not going to give us any meaningful insight. So it's just a burden to our computation. It's a burden to the time and space. So always better to avoid using such inputs. So avoid, so remove that from the data set. So doing that way, we can reduce the dimension of the data set. On the other side, if we try to find relationships between two input variables, and if we find it, any correlation between them, then we really understand that one feature is dependent on the other feature directly. If there is dependence of one feature over the other, then it simply means that one of the two features can be removed because both of them are talking about the same information. So unnecessarily having two features is going to be a burden. So whatever redundancy is there, so we can avoid using additional features which convey the same meaning, and hence we can simplify our data set and reduce the dimensionality, and through this the machine learning becomes easier because it speeds up of our learning and needs minimum space. So that's about a correlogram. So make sure that the correlogram is used to its full efficiency. Some best practices we need to look at to follow them. So we must use a diverging color palette to highlight positive and negative correlations effectively. So if you are trying to put this correlation matrix in terms of numbers, it may not be very much appealing because the number of features are high. So when the number of features are n, then the correlation matrix will be a n by n matrix. And if n is large, the matrix size will be too huge. And to show the whole matrix on one screen, we need to scale down, zoom out, and because of that, the each cell in the matrix it takes very small size on the screen, and the numbers put on that cell may not be properly visible. So then what is the next alternative? The next alternative is, instead of numbers, show with a color. So uh, every patch in that cell can be given a color, and that color talks about the magnitude of the value we are trying to show in that cell. The more magnitude means more positive correlation, a less magnitude. So more positive is higher positive correlation, a more negative is higher negative correlation. Zero means no correlation. That's what the standard is. So to represent with a range from the minimum to maximum, we need a set of colors to represent, so which we call it a color palette. So we need to select a color palette such that the extremes and the different colors on the way should have a better diverging color, so that you can easily understand that what is maximum, what is minimum. We should be able to distinguish everything very immediately, instead of just changing the brightness of the one particular color. Say if you are trying to use only blue color everywhere, and a larger number is a dark blue and a smaller number is a light blue, then it may not be immediately visible where maximum is, where minimum is, and all that. So instead of that, if blue is used for maximum and yellow is used for minimum, then immediately it catches where maximum is, where minimum is, and all that. So a diverging color palette is required to highlight these things. So make sure to annotate the correlation coefficients within each cell to provide numerical context. Then ensure that the variables present along the rows and columns are clearly labeled for interpretation. So the two axes should be properly labeled. That means what each row is talking about. So when you're talking about this correlogram, it's a confusion matrix. So it is categorical data you're talking about. So each row will talk about one class of one type, and each column will be talking about a class of another type or so, or maybe same types. The classes are arranged in row and column depending on the situation, and we must ensure that each row and column is properly labeled for interpretation. So better always to normalize or standardize the data if variables are measured on different scales to ensure fair comparison of correlations. Because even if there is a correlation, but if one is scaled up, other is scaled down, then it may either look like a vertical line, or it may look like a horizontal line, which we miss to see that there is some correlation. So before plotting, make sure that the data are normalized so that the variations are clearly visible. So those variables which have no meaningful relation or having limited variability, so please avoid them. So unnecessarily don't include all the variables which don't make sense to our discussion, and that will reduce the clutter and definitely will improve the readability of the plot we want to. What information we are trying to convey will be simplified, so it becomes easier for us to convey as we reduce this clutter. Unnecessary things we don't dump onto the plot, so that way it becomes easier. So we need to ensure no redundant relationships are used in our correlograms. So here one example of the correlogram. So it is trying to mention too many information is being dumped onto one plot. So something the data talks about the car mileage. It's trying to compare PC2 versus PC1. So, looking at the diagonal things, you can see that the first row, first column talks about gear, second row, second column talks about AM, third row and third column talks about DRAT, miles per gallon is the next one, VS is the next one, and so on. So on the lower triangle, we can see they are colored with, these cells are colored with different shades. Something is dark blue, something is light blue, something is grayish, something is light red, something is dark red, and so on. So that's what a correlogram is. So here, so if you look at the topmost left one, it's comparing between gear and AM, and it is showing a dark blue. So if we assume that dark blue talks about maximum, then it gives a maximum value for the relation between gear and AM. Gear and DRAT is a little dull, but still it's a darker blue. So it's almost a maximum, but little less than the previous one. And if you look at gear versus MPG, it becomes more dull, so it is more light blue. So there is no proper correlation between this, yet it is positive because it is showing blue. It is positive, but not very much. The slope is less compared to the gear versus AM. The slope is maximum, and gear versus MPG, the slope is little less, yet the slope is positive. And looking at gear versus VS, it's almost gray white line. So maybe the center one, so it doesn't have any correlation, so zero. Then getting down, we can see gear versus WT. It's a dark red, saying that is red means maybe negative correlation, dark means more negative. So it's talking about more negative slope and so on. Now on the other side, looking at the upper triangle, it is showing a different type of representation. There are circles are shown, and in the circle some area is being shaded with different colors. So that means one side it is trying to tell the amount of shade in that circle conveys one meaning, and the color conveys one more meaning. So there are different areas being shaded in the circles, and each shade has a different color. So a legend is missing here, so we are not able to make out exactly what they are trying to tell. So that's why we always keep telling that the labels, legends, title are essential. Otherwise, we don't understand a bit what one who has created this plot is trying to convey to us. If the legend was put side to this, we could easily understand the total message being conveyed to us. So that's a higher version of correlogram we are seeing, but in basic, it could be a simple correlation matrix. So it can be the whole matrix can look like only the lower part where only each cell is shaded with a color, and color talks about the correlation type, positive, negative, and the intensity can be, or this is talking about only uh, two ends of color, so it can also have multiple colors on the way. It can start from blue, go down to yellow, on the way various colors like green, red, and all that can be included. A proper palette can be designed so that the overall picture is very clear. Here it's still very clear what the author is trying to convey to us, but only legend is missing, so we are unable to make out the total meaning out of it. So that's power of correlograms, correlation matrices, and their presentations. So that's it for now. Thank you.